Okay, so hello everyone. In this video, we will cover introduction to operating system. So in this video, we will first see an introduction to operating system and then discuss the functionalities of operating systems like resource management, process management, storage management, memory management, security, like that. So first, moving forward to operating system. So what is an operating system? Basically, an operating system is a system software. It is a software which is in your system. Its basic functionality or definition is that it works as an interface between user and hardware. In very simple language, the operating system provides interaction between user and hardware. Now if we look at the diagram, which of these is a hardware? If we take the scenario of a laptop or desktop, what hardware basically include is the CPU, which we call the brain of the system. The input output devices, which include keyboard, mouse, printer, scanner, then the RAM, that we call the main memory, then secondary memory, the hard disk. These are the example of hardware. When we access all of these hardware components, when I am accessing my system, I am accessing these devices, but I am directly accessing those devices? No. Is the user directly accessing the hardware and devices? No. They are accessing through what? Through operating system. The operating system is working as an interface here. The second point is why is there a need of operating system? If there were no operating system, what would be the scenario? The scenario would be that if a user want to access particular hardware, they would have to write a program for it, and through that program they would always access that device. This means they would always have to write program to access those devices, different program for different devices again and again. When they write this many programs repeatedly, let's say I have to give a print command. I have a word file that needs to be printed, but I can't print it directly. First I have to write a program for it so that the printer will know that it has to print. Similarly, if we talk about CPU, if I want to execute a process or a job, the job execution comes later. First we have to give the CPU an instruction. And how will we give that instruction? For that we have to write individual programs. Because of that, the interaction between user and hardware becomes very complex. There could be another scenario also. It could be possible that one user is accessing hardware, and if another user want to access that hardware, the first user is not releasing it. Why? Because they are accessing the hardware directly, meaning there is no authority in between who can take back the hardware from them. So there are many reasons why we need to use an operating system that works as an interface between user and hardware. We will see that in the functions, all the functions of operating system can be called the reasons why we use operating system in our systems. If I give a basic example of operating system, the first operating system that's used by the majority is Windows. Why we are using operating system? The major goal of operating system is to provide convenience to the user. Yes, it provide convenience, meaning I can access my hardware in the easiest way. That is the functionality of operating system, and this is the reason why Windows acquired the whole market for many years. There was a time when Windows acquired 95% of the market. The whole market was acquired by Microsoft. They had this much popularity because the major goal is convenience, and Windows provide convenience the most. Why we are using Windows? Basically because of convenience, but gradually with time the problems that we were solving in our system started to get complex, and the value of time is increasing so much for the user that user wants their problem to be executed very fast. For that we need throughput. What does throughput mean? In simple definition, throughput is the number of tasks executed per unit time. The more number of tasks getting executed in a particular amount of time, the more will be the throughput. It means we need such operating systems now whose throughput is high as well as convenience is high. The maximum use in throughput is Linux. Although Linux operating system doesn't mean that it's not providing convenience. I am just comparing it because Windows acquired 95% of the market because of convenience alone. But now if we see at present, it is approximately like 80 to 82. Other than this, we have Apple's own operating system, macOS or Macintosh, that also runs well in the market. These are real life example like Windows, Linux and Macintosh, macOS, but the major goals are convenience and throughput. Now the next part that comes here is, what are the functionalities of operating systems? If I have installed an operating system in my system, then what are its functionalities? The major functionality of operating system is, first, resource management. It manages the resources. How do we manage resources? If I am alone using my system by myself, then at that point I don't need any resource management that much. Okay, but where there is a parallel access. When multiple users are accessing a system, this happens majorly at the server level. If we talk about a server where many users are sending requests to access some data, at that point the operating system is useful and works as a resource manager. How much hardware to be provided to which user and for much how much time, that is decided by the operating system. After that time, it will take back the device from the user. This is how we manage resources, so that there's no overload on the system. When we open the task manager in our system, you will easily get values showing how much percentage we are using CPU, how much RAM. All these values are managed by the operating system. The second point is process management. Process management means we are managing processes in our system. We are executing processes. I open the laptop and I'm working on Microsoft Word. Along with that, I open Windows Media Player also. Along with that, I have opened a gaming app also. I am working with the multiple process open. How to execute all these processes, that is also done by operating system. How does it work? Through CPU scheduling. Here we use CPU scheduling algorithm. CPU scheduling means if I wrote a simple program and saved it in .c file, and now I want to execute that program, then that program becomes a process. Now if we want to execute the process, where will we do it? At the CPU. How to execute that process at CPU? That is done by CPU scheduling. Other than this, we have storage management. Storage management basically includes secondary devices, that is hard disk. The data that we want to store in our system permanently, operating system manage how to store that data. And how do we do storage management? Through file system, NTFS, FAT32, ext4. These file systems are used in Windows and Linux. Their major goal is to manage how to store all data in hard disk permanently, how to store it in tracks or sectors in disk architecture. That is also managed by the operating system. Then the fourth one is memory management. In memory management, what we have here is RAM. Why have we separated storage management and memory management? Because storage management consists hard disk, and it's the operating system functionality to manage hard disk. But there's no major constraint of hard disk size. We have a constraint in RAM, limitation of size. RAM in our system is limited, and all the processes get executed first in the RAM. This topic is called the concept of multitasking or multi-programming. All the processes that we have to execute, we bring all of them first into the RAM, and then when they come into the RAM, then we transfer them into the CPU one by one. So how much memory of the RAM we have to allocate and take that memory back when the process is done? Allocation and deallocation. Because the RAM is limited, it shouldn't be like the process has finished executing but it's still in the RAM, and another process that wants to get executed is not able to come into the RAM. So what operating system does is, when a process is done, it takes it out and brings the another one. This is called swapping. Other than this, we have fifth functionality, security and privacy. It's also provided by the operating system. Whenever we turn on our system, what we first get is the password screen. So why do we put the password? So that authenticated person who has the proper password can access it. Windows uses security protocol to keep that password properly in the secured file, so that no one can access it. Other than this, in the RAM, as I told before, when we execute a process, it gets a portion in the RAM. Like it got a memory allocation 0 to 100, and another process P2 got memory allocation 101 and 200. If any process calls or execute any instruction outside the given segment, then that process gets blocked instantly. It's providing security between the processes, so that no process can interfere or change each other's data. So security and privacy is also provided by the operating system. As I wrote in the diagram, we have user applications also. What's the applications here? How do we access operating system as a normal user? If you notice, when you turn on your laptop, the desktop appears. That's an interface. We can go to my computer, can access data, we can access any movie or song in C or D or E drive. Okay, actually user can either access through applications or can access directly also. We use applications mostly. Like if I want to print a particular file, what I do is, first I will create that file in Microsoft Office. That's kind of application. When we press Ctrl P, then it asks, do you want to print? If yes, then you give the print command. What is the print command? Actually, we are accessing the hardware with it, but you are accessing the hardware through the application, and operating system is working as an interface here. Do you feel anything like that? No, like we as a user don't feel this. So it's providing such a nice interface that user don't even feel that what they are accessing the hardware or not. The other way is through shell. If we talk about Windows, we can access the operating system through command prompt, and in Linux we open the terminal and can write commands directly in it. That's through the command prompt. We have to write particular commands. That's called system calls. Operating system basically works through system calls. Whenever operating system works, it works through system calls. So whenever we are giving a command through application like print, then print will invoke a system call. Same way, if you are opening a file in C or D drive with double click, we just open normally with double click and file got opened. But how did operating system open that file? Through open system call. There are many system calls like read, open, write, through which operating system works between application, user and hardware. So these are the basic functionalities or goals of operating system that you have to keep in mind. In majority, it will come in your college or university level exam. So we will see all of these functionality in details in our upcoming videos. So that's it for this video. We will meet in next video. Until then, bye bye.